On lesson 1, you learn how to expand binomial expressions in the form 1 plus x to the power of n, in which n can be any real number. In lesson 2, you learn how to break down more complex fractions into partial fractions. In this lesson, you are going to learn how to use partial fractions with binomial expansion. In other words, how to expand binomials when you have fractions that seem complex. The best way to illustrate this is doing something with this working example. So imagine that you have this, and you are asked to find the first 3 terms of this expansion. At first glance, you look over there, and there's nothing you can do. But now you know how to divide this into partial fractions. So we first need to transform this fraction in expressions of the form 1 plus or minus ax to the power of n. Don't forget that you can just make binomial expansion when you have something in this of this kind. Okay? So first step, transform that in partial fractions. This particular example is a type 1. So just go ahead and break it down. I'm not going to explain again how to do this. I'm assuming that you already know how to do that. Here, I just did the appropriate calculations to figure out the values of a and b. So I already found them over here. B is -1 and a is what? A is 3. So I just substituted over here, and here I have the partial fractions. Now, second step. I can put the denominators in the form that I want. How? I can write this as, if I multiply the whole thing by -1, I will have -3. I multiply the denominator by -1, and this transforms into 1 minus x. And then I can write this as this. And now I have what I want. Look over here. What do I need? I need to put the denominators in this form. That's what I did. 1, in this case, is minus x to the power of -1. Do the same thing to this term. Okay, this is minus. And now, what did I do? I put the 2 first, just reverse the position of these 2. And then I factorize the 2. Remember, I mentioned this in lesson 1. Even when you have the first value as a different number that is not 1, you can factorize it. Okay, and then you put inside what needs to be put so that the factorization can take place. So this is 1. This is going to be turned into 1/2 of x. And I can write this as this. Again, what I have here already obeys the criteria that allows me to do the binomial expansion. Everything is ready. So on the third step, I just have to expand this and that. And I can pause my calculation here and do one of the expansions at a time, and then combine everything together. Okay, so let's expand this. You already learned in lesson 1 how to do this, so I'm not going to go over details on how to do this. Just go to lesson 1 if you still have doubts. I expand these. I expand this. The question asked me to get the first 3 terms, so I only need to expand until the 3rd term. This is what I have, so basically it ends up as being that. Do the same thing on the next one, 3 terms, and I end up with that. Just pay attention to this detail. Sometimes you are asked, sometimes you are not. The range of values from which this expansion can take place. Here you just have 1, so modulus of x is smaller than 1, meaning that x can be anything in between -1 and 1. Here you don't have x, you have x divided by 2, so you have modulus of x divided by 2 is smaller than 1, which means that the modulus of x is smaller than 2, meaning that it is valid every time x is in between -2 and 2. So which one goes to the final? That's the last thing I'm going to talk about. Just keep an eye on that. So fourth step, combine everything. Okay, so what is this? This is going to be equal to -3 times, and now I know what this equals, at least until the 3rd term, so I just plug it here, it's that. And over here I do the same thing, and I plug these 3 terms. Then I expand the brackets and combine like terms, and this is what I get. Now, for what range of values of x is this valid? Is valid for the one from these two that it has the smallest range. So if you imagine this as being set A and this one as being set B, you're going to do the intersection of these two, which always yields the smallest one. In this case, is that one between -1 and 1. So now you have a way to be able to expand, to make binomial expansion on fractions that seem complex. And your next step is now to solve exam questions that involve this type of exercises by first doing partial fractions on the overall more complex fraction, turning each one of the partial fractions of something of this kind. Where is it? Of this, I just lost it. Of this kind, sorry. Then expand each one, combine everything, see the set of values of x for which it is valid, and then everything will be done.